The objective of this lesson is to recognize and generate equivalent ratios by iterating or repeating a given ratio. In previous lessons, we learned that a ratio is a multiplicative comparison of two or more quantities. Today we will be finding equivalent or equal ratios. If we wanted to make orange juice, we would need orange juice concentrate and water. This recipe is made by combining 4 cans of water with 2 cans of orange concentrate. To model this ratio, we can use 2 colors of cubes. One color, orange, will represent the orange juice concentrate, and one color, blue, will represent the water. This shows that for every 2 cans of concentrate, we will need 4 cans of water. Let's put this ratio into a table. What if we wanted to make more orange juice that would taste the same as the first batch? We could double the original recipe. We will now have 4 cans of concentrate and 8 cans of water. What is the ratio of our second batch? For every 8 cups of water, there are 4 cans of orange juice concentrate. These are equivalent ratios because the quantities were multiplied by the same factor, 2. Another way to find an equivalent ratio is to make repetitions or iterations of the original recipe. 3 iterations produces a recipe with 12 cans of water and 6 cans of concentrate. This is the same as multiplying the original recipe by a factor of 3. This new recipe is equivalent to our original recipe. When we have 2 ratios that are equivalent or equal, they are called a proportion. We can begin to see some patterns or relationships. The chart now has 4 batches with appropriate ratios. Let's look for some relationships between the ratios or proportions. The terms in the concentrate column are half the value of the water. We could divide each of the terms for cans of water by 2 to get the amount of orange concentrate needed for the batches. Our table also shows that the terms in the water column are twice the value of the terms in the concentrate column. Another pattern exists going down the columns. On the concentrate side, 2 is added to each row. On the water side, 4 is added to each row. This is known as additive reasoning. The table of recipes contains pairs of equivalent ratios. Equivalent ratios name the same comparison and have a proportional relationship. The terms in a ratio are linked so that when one term changes or is multiplied or divided by a number, the other term also increases or decreases by the same factor. This is called covariance. This means the 2 terms vary in a precise way together. The relationship stays constant. Let's look at one more problem. For every car, there are 4 tires. One way to represent this ratio is by using 2 colored counters or discs. If our ratio is 1:4 for car tires, then how many tires for 5 cars? Notice that we can copy or iterate the 1:4 relationship again and again to represent how many tires will be needed for 5 cars. Let's create a table to help record the iterations for cars and tires. As we record the iterations of cars to tires in our table, what are some of the proportional relationships or equivalent ratios we can see? When the terms are in order, we can see an additive pattern going down the column. Notice the numbers of cars is going up by +1 each time. The number of tires is going up +4 each time. Let's look at the proportional relationship for 1 to 5 cars. We could find the covariant relationship by multiplying the number of cars 1 times 5 to get the number of cars and multiply the number of tires for 1 car, 4, also by 5. The new equivalent ratio or proportion would be 5:20. The objective of this lesson was to recognize and generate equivalent ratios by iterating or repeating a given ratio. We met this objective by using blocks to model the ratios and then creating a table that shows the iterations or repetitions of the ratios.